This is Dr. B, and let's take another look at the Aufbau order for the electrons as they reside around the nucleus of an atom. And let's simplify things a little bit by using shorthand notation. This is a popular tool for students since it's less work. Let's begin with a little quick review of the Aufbau order. You can simply read the periodic table to see where the electrons go as we go from smaller atoms to larger atoms. And there's disconnect when you do that. You see that they do not fill up from the first shell in order to the seventh shell, despite what you might have learned earlier on. An interesting ramification of that is that the outer shell of any atom can never have more than 8 electrons. And all of them will have 8 electrons, with the exception of hydrogen and helium, which don't have that enough shells to do so. They either have 1 electron or 2 electrons. That's it. The rest will always end up with 8 electrons in the outer shell. They call that the octet rule. Fine. So as we progress through the periodic table, let's read it like a book. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. It's lower energy for it to start repopulating that third shell. 4p6, 5s2, go back down to the fourth shell, and then up to 5p6. And since we dropped no shells for the first two, for the fourth and fifth shell, we drop 1. For the sixth and seventh, we drop 2. 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, etc. So there's a patterns within patterns, and there's a certain beauty to that. I just like that. There's how things really go. Bing, 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 bing. There it is, what we just said. Fine. But, let's introduce shorthand notation. Since it's always the same darn repeating pattern, maybe we don't have to say the whole thing. Do we really have to say 1s2, 2s2, 2p6, 3s2? Maybe we could just say, I don't know, use the nearest noble gas to imply all the stuff that is neon, the first 10 electrons. We do that. They use square brackets. The electron configuration for magnesium using shorthand notation is neon 3s2. I should point out that you can take it even further. I mean, nothing varies till the last one. You could just say ends in 3s2. When I write a test, that's how I usually do it. What does it end with, right? But shorthand notation is allowing students to use the nearest noble gas, since neon has always got the configuration of 1s2, 2s2, 2p6. Try it for scandium. If you got that, you should have this down. Well, the nearest noble gas, and by the way, you only go down, not up, has to be argon, which fills up 18 of them. So proceed after argon, which is right there, 2p6. And so we only have to say argon, 4s2, 3d1, and that would be the electron configuration using shorthand notation for scandium.